This is a total revision. Topic wise, I tell very important point. Then you search the answer. Then one time you just search the answer. Then second time, once you read it, you can automatically remember the answer. Because if I am giving that question and answer both, you will forget everything. Okay, now interaction. I am asking one by one. Just whatever you remember, you tell. What is the heat rate?
Kilocalorie by kilowatt hour, sir.
Heat rate. What is the heat rate?
Joules.
How much kilocalorie is required? How much kilocalorie is required to generate 1 kilowatt hour of
Power generation. Okay, that is okay. Very good.
power?
And heat rate versus thermal efficiency.
So
What
heat
is the
rate is
difference?
inversely proportional to heat rate is inversely proportional to efficiency.
Okay, that is good. Next, 1 kilowatt hour equal to how much kcalorie and kilojoule?
860 kilocalories, sir, and 3600 kilojoule.
Kilojoule. Kamal, can you understand? Na?
3600.
Okay.
Yes,
Next.
yes, just I am reviewing.
Okay. Because if I am giving the answer, every time you are seeing the with the answer question, that time you will forget. If you are giving the without answer, you can easily remember. That point always you get it.
Okay.
Next, cascade efficiency. What is the cascade efficiency? What is difference between generation stress to end user? Only the transmission dismission. What is the difference?
So
1 mark. This is very important 1 mark. Calculation. Only they will give the calculations.
So generation
Yes, full.
to end user, we have to calculate from generation to end user full from means N1 into N2 into N3.
Okay, full efficiency. Suppose they give the losses. How to calculate the efficiency? I'm telling
Only losses.
2% losses. How to calculate the efficiency? Suppose generation, sorry, here transmission, main transmission here 2% losses. Efficiency how to calculate? Because this is totally efficiency multiplication.
So divided by 100.
No, 100 minus 2%.
Yes.
Then 98% efficiency. Then you once you calculate time, you calculated 28% means 0.28 into 0.98 into like this. What is the cascade efficiency, transmission, dismission?
Yes, sir. From transmission means N2 into N3 like that.
Okay.
From N2 we have to start.
Generation.
The generation we have to left the generation.
Okay. Next, distribution. Main important is the distribution. Suppose distribution side voltage 11 kV to 33 kV. What is the ratio of voltage drop? Line loss. It's very important. 1 mark.
Voltage drop will be 1/3, sir.
Okay. Line loss?
1/9.
Okay. Next, if industry side, if I'm using that 1 unit, then how much unit I need to generate?
To save 1 unit.
Yes, I'm suppose I am industry side I am using 100 kilowatt hour. Okay, then how much kilowatt hour need to
200
generate?
kilowatt hour.
Okay,
200 kilowatt hour.
okay. 1 unit means 2 unit generated. Okay,
2
this
unit is generated.
okay. This everything I'm not telling any answer. You have to tell, and again with this one you have to study. Then you have to tell again. Okay. And what are the tariff system? Can you understand now? HT, what are the tariff system?
Energy charges, power
Okay,
factor penalty,
okay. Main part of the
meter rental.
HT
Yes.
line, they will ask 1 mark. Two HT line, 2 types.
Okay, okay.
Main important. Remaining tariff system also available, but HT.
Okay, okay.
Now also we have calculated na.
Maximum demand charges.
Okay. Next.
Energy charges.
Okay. Okay. Another other tariff system. Just tell randomly. No need to sequence. Whatever you know, just tell.
மேக்ஸிமம் டிமாண்ட் தாண்டிட்டா நம்ம அதுக்கு ஃபைன் கட்டுறது.
Okay. Other power factor
Power
incentives,
factor.
penalty. Okay.
Yes. Penalty.
Meter
Meter rental.
okay.
Meter.
Same energy charges, demand
And
charges.
time up.
This
Oh,
you
sir.
understand? HT only they were high voltage line. They use maximum demand and the energy charges. This general tariff system same include
Okay.
energy charges, maximum demand, power factor penalty, meter rental. This is only they asking the HT, and this is tariff system whole.
Okay, okay.
This is a 1 mark they will ask. Can you understand? Na? This remaining everything. What are the you have to go through it, this one. How to improve the power factor?
By using capacitor bands.
Okay. Benefit of power factor.
I square at power losses reduced.
That's a benefit of power factor.
Voltage.
Tell me.
It reduced the I square losses.
Okay.
Voltage level will increase at the load side, sir.
Okay.
Load end side.
Okay.
And
Charges, penalty charges are reduced.
Okay. Very good.
KVA, reduced KVA.
Okay.
Or maximum demand.
Okay.
Maximum demand reduced.
Okay. At least you have to collect
Distribution losses
5 points. This one. Okay.
Okay, okay.
Okay. And industries.
Better
Already,
voltage.
tell me, Ganguly.
Yes, sir.
Tell me. Okay.
Advantage
Next.
and disadvantage.
Okay.
Sir, better voltage.
Yes. Better voltage. And industry. If you are Veeramani, you are using finance, na? They are available motor available. Suppose if you are using motor end, only one motor.
Improve performance.
What is the advantage
motor.
and disadvantage?
At industry various disadvantage at various.
Same
locations.
benefit of power factor improvement
Like
you
motor.
tell to here, and disadvantage add.
Near motor side capacitor connected.
Okay.
voltage is standard.
Okay. Better voltage improvement, motor terminal.
Yes, better voltage.
That
Yes,
keyword,
yes.
very important.
Yes.
Next.
Yes. Disadvantage.
And load current also reduce. I square R, very,
Yes,
very
yes.
important. Once they will ask the power factor benefit, then all the point you have to repeat every time. Can you understand? Na? I square loss reduce,
Yes, yes.
better voltage regulation, and motor this voltage boosting. Same, you have to write it everything, repeat it. Current, load current reduce, main important, full load current reduce. Full load current reduce, then I square loss reduce. Then better voltage improvement. Then disadvantage for only the one motor. Suppose one motor, single motor using.
Is cost.
Yes, cost wise.
Uh, actually, small. It cost will be more, sir,
Okay.
than the larger units.
சார் கெப்பாசிட்டி அப்படி அதிகமா ஆட் பண்ணாலும் மோட்டர் இதாயிடும். ஏதோ வைண்டிங் டேமேஜ் ஆயிடுமா சார்?
அது கிரிட்டீரியா இருக்குது, கிரிட்டீரியா செலெக்ஷன் அதெல்லாம் இருக்குது. இது வந்துட்டு டிஸ்அட்வான்டேஜ். இப்போ வந்துட்டு this is for the disadvantage. We are going to install the motor end, final condition, final stage. Main important, we cannot dismantling. Is install cost high, capacitor cost also high, but this is a more, because only one motor we are using, this cost also high. This is enough. For next gang operation, what is the advantage and disadvantage? Gang operation motor. Kamal, whatever you know, just tell. If you are using for 10 motor for capacitor,
Okay.
what are the benefits and disadvantages?
Actually, if the power factor is not maintained properly, all the gang operation for how much motors connected, all motor will be affected.
We cannot separate. This is disadvantage because 5 motor, suppose
Yes.
we need to, then it is very, we have to consider that all the 10 motor that we need to consider according to that.
Otherwise, yes, because maybe if we can separate it by a load center or like this, we can maybe separate it maybe 3 motors from the another load center and another 4 motors from another load center and another 3 for another center like this. But
Like
even
this,
if it is doing like this also, we
But-
can, yes, using only one capacitor, maybe it will affect all motors. The same time.
yes, this is the main disadvantage is installation cost list, but separating, but that means we cannot separate it for 5 gang operation, only gang operation we cannot separate from other motor. Then cost wise,
Maybe if we can use like 2 bus and 2 incomer method, we can connect separate 2 reactor means maybe we can connect.
we can connect, but
It will not affect.
it will not affect, but they will already install the gang motor for 10 motors. Then installation
Okay.
costs reduce and investment costs reduce. That is 2 benefit. Disadvantage, we cannot rearrange this one. Suppose 5 motor, we cannot separate for 5 or for 5 motor, 3 motor.
Okay.
It's
So
not
already
possible.
they are in the cost reduction plan. Already they
yes.
are in the cost reduction plan. So they are using gang operations.
Cost reduction they will do it, but disadvantage is another side also available. So we have to consider everything.
Okay.
Next, incoming side, incomer side, they are using secondary side. Secondary side always connected to sun's parallel connection. Incoming side, what are the benefit and advantage and disadvantage?
In secondary side means load side, huh?
Second, yes, load side. load side, suppose incoming side also connect. Basically, they point out everything. Primary side and secondary side, not in load side, incoming side. What is the advantage
Okay.
and disadvantage?
No, actually, I don't have idea.
Okay,
about this.
I will tell. Veeramani, Ganguly,
Yes, sir.
yes. Anyone know? Tell me. No issue. This is we are in interaction. We are interacting ourselves.
Sir.
Just you
Can
think this is just incoming side means insurance cost reduce. Understand? Material cost reduce because we are considered total. But
yes, sir.
disadvantage is a load side not maintain the proper moldage. Load side moldage maintain not possible. Okay, power pattern that also power pattern improvement very difficult. Load side. These are disadvantages. Next,
Yes, sir.
capacity selection criteria. If you are going to select the capacitor for one motor and transformer any other, what is the main criteria? One every time they asking one mark.
The capacitor selection
Yes.
criteria
Uh,
means
only main important one point. Every time they asking one mark.
means where to put the capacitor or
No. Material selection. Capacitor,
the
KVR, how
material.
much KVR selection? Basically, we calculation, but the sometime calculation maybe will high.
Based upon the power factor,
Okay, power factor.
Actually, the to reduce the maximum demand.
No. That
we-
is we are doing calculations. But suppose motor is a small motor. Only I going to fix the only that motor. We are calculating higher value KVR. That is not possible to install the motor in.
the voltage level and the current consuming capacity.
Okay, that also that voltage and current also mandates current and main important no load magnetism KVR not greater than suppose no load condition we have to measure the KVR no load magnetism KVR not greater than no load KVR magnetism KVR that is very important one mark. It's a very capacitor once we are going to select that we need to consider. Then whatever is a voltage, that is a voltage and material. What are the material use? Material selection.
Sir, repeat it.
Material capacitor material selection. What material using?
Amorphous.
Capacitor. Okay, that I will one time I will show you everything. And capacitor connection location.
Hello.
Near to the load center
Oh yes, okay.
or transformer.
Near to suppose transformer side connection. Which side we need to connect?
LV side.
LV side is that is sun type we have to connect to. Suppose we are using series capacitor, where need to connect? What is the purpose? Series capacitor. Voltage boosting.
Okay.
Transmission line using. And voltage effect. If you install that capacitor, suppose site voltage and rated voltage is different. What is the voltage effect on? That is one formula available. Here I will write it. How much kVR produce? One formula is available, na? Vn square divided by Vt square. Vn square is a site actual voltage. V2 divided by Vt square rated voltage. Very, very important one mark. Vn square, V2 square. Vn square equal to what is this? Is a site actual voltage. Is a rated. Okay, square. Actual divided by rated, then you put it to whole square. Easily, quickly you finish. Next, very, very important. Suppose distribution tail end, you are improving the power pattern. Okay, power pattern 1. Suppose power pattern 1 to power pattern 2. What is the formula? And percentage relation. One formula available, na? Okay, I will show this one, everything. Can you hear my voice?
Yes, yes.
Okay, wait. This is already we have seen the location of capacitor. Can you understand? Here, load side, it's a gang operation and incoming side. Just one side, read it. Again, you go to that question, you remember everything easily. You can easily remember. This is a tail end power factor improvement. Reduction in the distribution losses, very, very important. 1 minus power factor 1 divided by power factor 2 square into 100.
Also.
Okay.
Okay.
This is a main important, these two. And next, voltage. This is a V1 square divided by V2 square, voltage effect. And material selections. We have selected dielectric material that likes paper polypropylene. And connection, shunt capacitor connection, almost industry end user application. Series capacitor using voltage boosting. Then what you need to consider about this next one, selects where once you are going to purchase a capacitor, you have to see the nameplate detail properly and charging current and terminal insulated or not. We have to check everything open and check. And the capacitor single phase motor using, don't use for the lighting purpose. This is everything you have to consider. This is a main important capacitor. Next, load management, maximum demand control. What is the load management, maximum demand control? What is the benefit load management? Same capacity
To maintain the
improvement.
power factor constant.
Okay. And maximum demand they will reduce, and main important they reduce the cost, maximum charges, because load management they will shift the load peak hour to non-peak hour. Then one step by step process available. Same power factor improvement benefit, same repeated answer you have to write it. Maximum demand charge reduce, and load current reduce, I square loss reduce. This everything we have to write written. This is a step by step maximum demand control. This is one step by step. And one more point I need to add it. It's a meter. If you are using the meter, energy meter we are using now. That what are the criteria we need? This is that meter need recording and high accuracy. Energy meter, you know, the electronic meters. That everything, and
Yes, yes.
annuity of time of day tariff. Time of day tariff means peak hour load, non-peak hour, everything. That measuring, tamper detection, recording, proper recording. Main important is a very important one mark. Total harmonics reduction. Okay. Then lifelong is a benefit. Lifelong maintenance low, and remote data access. Whatever the points you have to know, just 2-3 points. They will ask only 2 mark or 3 mark. That load management, main important, they will reduce the tariff, penalty reduce, maximum reduce, and they improve the system, everything. Incentives they will get it. What is the step by step process? This is very important. 5 mark, 5 mark. Only you have to write it. This 5 point.
Load curve generation.
Just max demand control, step by step, how to control. If you are an energy auditor, you are going to the plant, just you see the load curve you are see. Load curve, graph, what are the graph available? You just see the load curve, peak, maximum demand, and load, which load is high, which hour is very high, just you see the load curve. Then access everything, then scheduling the load. You know which load, utility load means a lighting load. This utility load where we shift. It's a peak hour, non-peak hour, you have to rescheduling the load, everything. And ice bank, storage, the ice bank that we are using, the ice bank, no need to necessarily to use a peak hour. They will, you tell to non-peak hours, that night time also they will storage the ice bank. Then they utilize the daytime. Two type of load energy we can store. One is a battery, DC charge we can store. Another one is a ice. It's a cooling load. That also we can store full day. Then full night we can use. Then storage. Then daytime we can use. Storage protector process. That is where you process material. Many more available. Food industries every day they are using this one. And setting non-essential, you have to off and again use. It's a 1 meter available. It's a direct demand metering control system. They will not ask deep level, just you have to write it the 5 points. One is a first load curve analysis, second is that load you have to shift, reset the shift. Next step, what are the ice bank, what are the food industries and the storage product, which are they using the ice bank. you tell to them, you have to use non-peak hours, storage the ice bank, then use the daytime. Next one, setting. Set non you are seeing that a power plant, many more motor not running. They will run, not use. Then setting the non-essential load. They will not use 24 hours, just 5 hours, 10 hours. Then again, that motor you can utilize. That purpose using. Then very important, maximum demand. DC captive power generation, DC generation. We have to reduce the maximum demand. Suppose all the load necessaries, that motor very necessaries, then they need to run. Then if you are running all everything, then maximum demand increase. Then you have to run standby DG. Then you reduce the maximum demand. Can you understand? Na? You cannot switch off the any load. That load very important. Then what do? You switch on the DG, reduce the maximum demand for particular hour, 3 hours, 4 hours, then off, no issue. Then reactive power factor improvement, reactive power capacitor install, then reduce. Totally 6 steps. Just you can analyze. First you are going to plant, analyze the load curve, then rescheduling, then one job completed. Then what you do? Product storage system, what are the food industry and refrigeration system, just tell them use the ice bank they using storage at non peak hour, night time, then use the peak hour, that load. 3 steps completed. Then many more motor not running, so setting the non-essential load whenever need, then you can run automatic system. Next one, DG. What is the purpose? Maximum demand reduce. Next one, power factor improvement, reactive component. That is 6 point. This whenever you see this all the point you have to, okay, this 3 point everything include. One time you read it, you just come and go through it, easily understand. And distribution power transformer, you know the transformer ratio. What is transformer? How to calculate it? Turns ratio.
V1 by V2 equal to N1 by N2.
Okay, V2 divided by V1 equal to N1 divided by N2. Okay, and diversity factor.
No idea about this one.
Okay. Diversity factor always greater than 1. Total connected maximum demand divided by maximum demand, plant or maximum demand. Suppose you are generating 20 megawatt, but load connected 40 megawatt. What is the diversity factor?
2.
Okay. What is the purpose? Why you need to this one, diversity factor, and what is?
Actually, we need to maintain the diversity factor 1 because the load is more, so we can't able to maintain the power factor. It will impact.
No, power diversity factor. Why need to greater than 1? Your voice break. Greater than benefit or purpose? Because no need to diversity factor greater than 1 reduce the cost of generation, because they will using 20 megawatt power generation for 40 megawatt, then they will load management system perfectly they will doing. Can you understand? Na? 20 megawatt using
Yes,
daytime,
yes.
another 20 megawatt night time, like this. They will for 24 hours 20 megawatt, but Total connected load 40 megawatt. Like this, and environmental benefit, and no need to extra power plant. Another 20 megawatt, no need to invest, no need. So load management very very important. Then demand factor,
Yes,
demand factor.
Less than 1.
Okay. Less than 1 formula. Same inverse. Maximum demand divided by connected load. Then it is less than 1. Same, it is same purpose they are using. And type of loss.
Transmission loss, generation loss,
No, type of loss is only transformer. Is it
core loss, iron loss,
okay?
no load loss.
Okay, load loss and full load loss. So no load loss different. What is type?
No load. Hysteresis losses, eddy current losses.
Okay. And calculations.
Loss calculations. Formulas we need to go through.
Okay. Just I will show you. Same. Before you see the losses. Same this formula. One time go through it.
Yes.
Two, 3 times, 3 times write it. It is very useful. Then what is the control? Voltage control. What is voltage control on transformer? How to control
RTCC, tap changer control,
Okay.
OLTC, and on-load tap changer, off-load tap changer.
Okay. What is the benefit of on load and off load? How do they using?
On-load we can interrupt the we no need to interrupt the power, and it will automatically sense the LV side voltage, and it will raise the HV tap change, and it will
Okay.
maintain the voltage. But off-load we need to interrupt the power during tap changing, maybe 1 minute or 5 minutes like this. We need to make shutdown, means interrupt. After that we make the tap change, then we need to make again retain. So that is the basic difference for on-load and off-load.
Okay. Veeramani, parallel operation. Can you tell me the parallel operation?
Parallel option, the power voltage should be same, frequency and impedance and phase sequence, everything should be same.
Okay. Veeramani, tell me. Your voice. No. Ganguli,
yes, sir.
tell me parallel operation. Criteria.
Uh,
Parameters. What are the
Criteria will
parameters?
be the parameters will be the same phase angle
Okay.
between the primary and secondary terminal.
Okay.
Same voltage
Both
ratio,
transformer.
same impedance percentage,
Okay.
same phase sequence,
Okay. Told. Okay.
and same polarity.
Okay. What is the benefit of using same percentage of impedance? Both transfer percentage impedance, if you are going to choose, what is the benefit? Main benefit one.
It can reduce the losses.
Current
Circular-
circulation is
Okay.
Yes, circulating current.
Circulating current reduce. Okay, very good, very good. Very, very important one mark.
uh,
Excuse me, sir.
Yes.
Sir, can I leave, sir? I have 9.
Hello.
Hello.
Tell me, Ganguly.
Sir, can I leave? Still I have night shift.
Okay. You leave. Now also 9 o'clock. Tomorrow we will see. Tomorrow, Kamal.
Yes.
Same 7:30. 7:15. We will connect, na?
Oh, okay, no issue.
Okay,
No,
okay,
see.
okay.
Then remaining 7 seat available. Tomorrow we will finish complete.
Okay,
This
okay.
plan is
Okay.
next week. Itself.
Evening, sir.
Yes, evening. Same time.
Okay, okay.
Okay.
Okay, sir. Then I'm leaving, sir.
Okay. I will share that link, LinkedIn.
Yes, sir. Yes, sir.
Okay, just
Okay.
share your thoughts, everything.
Okay.
Yes, sir.
Okay, come. Okay. One second now, photo எடுத்துக்கிறேன்.
Okay. Okay.
Hi. Today we are conducting interaction section. Total chapter revisions. It's going on. Totally very useful. If you want to join our classes, if you want to be in energy management system, this energy audit exams very useful for each and everyone. ஓகே கமல், நான் லிங்க் அனுப்புறேன். நாளைக்கு உங்களுக்கு லிங்க் அனுப்பிடுறேன்.
Okay. Okay, sir.
Okay.
ஓகேங்க. இப்போ வந்து உங்களுக்கு எப்படி
Okay, John, no problem.
எப்படி இருந்துச்சு? இப்போ பார்த்தோமே ரிவிஷனுக்கு, இது எப்படி இருந்துச்சு? இருங்க ஒரு நிமிஷம்.
இல்ல அது ஜஸ்ட் 1 செகண்ட் நான் அது ஃபுல்லாவே அந்த டாக்குமெண்ட் எல்லாமே நான் கோத்ரூ பண்ணி ப்ராப்பரா ஒரு வாட்டி பார்த்துட்டேன்னா ரொம்ப ஈஸியா இருக்கும். ஜஸ்ட் இது வந்து நான் இங்க அட்டெண்ட் பண்ற கிளாஸோட சரி. இதுக்கப்புறம் டைம் இல்ல.
இல்ல
அது
டைம்னு இல்ல.
உட்கார்ந்து அந்த இது படிச்சிட்டே தான் இருக்கேன்.
இல்ல அதை படிங்க. இப்ப நீங்க படிக்காததுக்கும் இப்ப பாக்குறதுக்கு எப்படி இருக்குது? படிக்கலனாலும் இந்த பார்க்கும்போது என்னென்ன இருக்குன்னு தெரியுதுல்ல உங்களுக்கு? இல்ல
Yes, yes.
ஜஸ்ட் நம்ம என்னென்ன கவர் பண்ணிருக்கோம் இது டிஸ்கஸ் பண்றத நமக்கு ஹலோ
ஹலோ.
அதான் நம்ம இதுவரை என்னென்னலாம் கவர் பண்ணிருக்கோம், என்னென்னலாம் நம்ம சாப்டர்ஸ் வந்து பார்த்திருக்கோம்ன்றது நமக்கு இதுல ஒரு நல்ல ஒரு ரிவிஷன் மாதிரி இருக்கு.
ஆமா. இப்ப ஏன்னா
Yes,
இதுல
yes.
வந்துட்டு நமக்கு வந்துட்டு நீங்க படிக்கிறத விட அதுக்குள்ள என்னென்ன இருக்கு அப்படின்னு தெரிஞ்சாதான் நீங்க வந்துட்டு கொஸ்டினுக்கு ஆன்சர் பண்ண முடியும்.
ஆமா, அந்த மெயின் அந்த ஓவராலா பாயிண்ட்ஸ் வந்து நம்ம ஓரளவு டிஸ்கஸ் பண்றப்ப நமக்கு நிறைய இது யூஸ்ஃபுல்லா இருக்கு.
ஆமா, இது வெரி
Yes, yes.
இம்பார்ட்டன்ட். ஒன்ஸ் one chapter you analyze all the points available. Okay, your mind remember whenever you read you can easily get all the points. Whenever you see the question paper, okay, you can easily write all the concept.
Yes.
It's a focus. First
Yes.
you want to understand what are the points available in the chapter. I can do it, I can record all the video, I can send one time, but you want to know about what are the points available. It's very important. Okay, Veeramani, you understand na? Now next tomorrow you will see na old chapter what are the points available, transformer losses what are you available, then capacity you take what are the capacity, what are the benefits, voltage effect, the power pattern, everything you can easily understand. If you go into load management you can easily understand that 6 point. One chapter take everything finish, total cover.
Yes, yes.
Yes. Okay.
Okay,
Actually, அவர் மட்டும் தான் கிளாஸ் ஃபுல்லாவே அட்டெண்ட் பண்றாருன்னு நினைக்கிறேன். எல்லா கிளாஸ்.
ஆமா,
வீரமணி மட்டும்.
ஆமா,
எப்போ
அவர் இப்படியே
எல்லா வீடியோலயுமே இருக்காரு.
ஆமா, இவர் இப்படியே பண்ணாருன்னு வச்சுங்களேன். அது பாத்தீங்கன்னு வச்சுங்களேன், இந்த மாதிரி தான் கேட்பாங்க. ஈஸியா எழுதி போடலாம், ஃபர்ஸ்ட் மார்க் கூட வாங்கிடலாம். அதான் எங்களுக்கு மெயின் இம்பார்ட்டன்ட் வந்துட்டு சாப்டர்ல என்ன கான்செப்ட் இருக்குது அது
ஷேர் பண்ற எல்லா வீடியோலயுமே அவர் இருக்காரு.
ஆமா, இங்கிலீஷ்லயே வந்துருவாரு.
இல்ல இதுல வந்து இல்ல சார், நம்ம புக்ல தியரியா படிக்கிறதுக்கும் இதுல கொஞ்சம் நல்லா ஒவ்வொரு வரையும் ரொம்ப யூஸ்ஃபுல்லா இருக்கு.
ஆமா, அது வந்து புக்ல படிச்சுக்கிறதுக்கு என்னன்னா நம்மளுக்கு படிப்போம், ஆனா மைண்டுக்குள்ள ஏறாது. அது இம்பார்ட்டன்ட்.
ஆமா,
இப்ப நம்ம நாங்களும் எல்லாமே நம்ம எல்லாம்
ஃபீல்ட்ல ஒர்க் பண்றோமா,
டிஸ்கஸ் பண்ணும்போது தான்
ஃபீல்ட்ல
நமக்கு
ஒர்க்
தெரியும்.
பண்றப்ப நிறைய யூஸ்ஃபுல்லா இருக்கு இது வந்து.
ஓகே ஓகே
ஓகே சார்.
ஓகே, நாளைக்கு பார்க்கலாம். ஓகே, குட் நைட்டுங்க. நான்
ஓகே, தேங்க்யூ
Okay.
சார்.
லிங்க்டின் லிங்க் அனுப்புறேன். அதில் கரெக்டாக போஸ்ட் பண்ணிவிடுங்க, என்னென்ன லேர்ன் பண்ணுறேன்னு. அப்புறம் யூஸ்ஃபுல்லாக இருக்கும் ரொம்ப.
Okay.
ஓகே
ஓகே ஓகே
ஓகே, பாய், குட் நைட்.
தேங்க்யூ சார்.
ஓகேங்க.
Okay. Okay.